Example 8-31. We are still working in Chapter 8, Section 6. And this is another one that is exploring the connection between doing a hypothesis test and constructing a confidence interval. And so we'll see, again, we'll see agreement between these two different ways of thinking about the same type of research question. So in this example, the theme is on hog weights, the weight of a hog, I guess. The researcher claims that adult hogs fed a special diet will have an average weight of 200 pounds. A random sample of 10 hogs has an average weight of 198.2 pounds and a standard deviation of 3.3 pounds. At alpha equals 0.05, can the claim be rejected? Also, find the 95% confidence interval of the true mean. All right, so yeah, just paused and recorded the pertinent information. Mu is 200 and the sample size is 10. Chi-bar, they told us, was 198.2. And then it turns out it is S, not sigma, is 3.3. So let's get started. Step one is to write down the hypotheses. And so here it turns out what the claim was, the researcher claimed that the hog's average weight will be 200. So this is the claim, mu equals 200. And here we're just trying to substantiate this claim. If it's under, it's false. If it's over, it's false. So we're just saying it's a simple two-tailed test. Step two is we'll sketch the critical region and find the critical values. Now, this is the t distribution because notice we were referring to the sample that had a standard deviation of 3.3. So we have the sample standard deviation S. And so that means that we have to use the t distribution. We have a sample size of 10. That means we're using the distribution that has 9 degrees of freedom. And we're using alpha equals 0.05. And so that gives us critical values of plus or minus 2.262. So we find the boundary values for our critical regions that we're shading here and here. Okay, let's continue on. Step three is we're going to go ahead and calculate the test value. So this is the t-test for a mean. So t is computed by chi-bar minus mu, all divided by s over the square root of n. And so 198.2 minus 200.0, all divided by 3.3 divided by the square root of 10. And so, according to the calculator, we get out negative 1.72. All right, so where is that? Negative 1.72 is down here. Okay? But it's not inside the rejection region, so we don't reject H subscript 0. And let's summarize that. And so I'm just going to summarize it as the evidence supports the claim that the average weight is 200 pounds. I'm just going to say it like that. Okay. Now, we're going to move on to the second part, which is to construct the 95% confidence interval for the mean. And the way that I do this is I start by constructing our margin of error. So this is our critical t-value times the sample standard deviation divided by the square root of the sample size. So, all right, so we plug everything in, and notice since we have the same alpha, and since here we're talking about a confidence interval, and in the hypothesis test it was a two-tailed test, notice we have the exact same critical t-value. It's still 2.262. And the rest of the calculation is we're going to plug in 3.3 in place of the sample standard deviation and then divide by the square root of 10. So what this works out as is 2.4 after rounding. Our margin of error becomes 2.4. So I say it like this, chi bar plus or minus e, that's what mu is equal to, but really that's not it. It was 198.2 plus 2.4, and that would be the upper end of it. And then we do 198.2 minus 2.4, and that is the high and the low of the range that our parameter could be between. So 198 minus 2.4, okay, so that becomes 195.8. Okay, so here we're saying mu, the population mean, could be anywhere between 195.8 and 200.6. So notice this, our population parameter is contained inside this confidence interval. And so that means that we fail to reject the null hypothesis. That is equivalent to saying, okay, look, when we compute the test statistic, it is inside the middle interval there. It's not on one of these extreme ends, also known as the rejection region. So we fail to reject the null hypothesis whenever the population parameter is in our confidence interval. If it is outside of our confidence interval, then we would reject the null hypothesis because the corresponding statistic would be in the rejection region. And so that concludes Chapter 8. We are not done with hypothesis testing quite yet. In Chapter 9, we're going to be doing more, I guess, more complex types of hypothesis tests. Yes, not really complex. It's just we're comparing more than one single population parameter. In this case, we're going to be comparing two population parameters to one another and testing our claim as to whether they're the same or different. All right, so that is for Chapter 9, and that is for Friday's lecture.